Alrighty. Hello everyone. I want to thank you all for tuning in to my video on my update for CIT 490 and the project that I'm implementing here. Um, there's a lot of updates, uh, and I've done a lot of work since I've last made a video and last made a journal. And so I guess some of the different things that I want to talk about, I have listed here on my notepad. And there's even some things that aren't listed that I'll kind of talk about and hopefully go over with you guys. So I guess let's go ahead and just kind of boot up my game so I can kind of show you everything that's going on currently. As you can see here, it's pretty similar initially to what it was. I've actually changed my avatar for the game, and I've actually I self-made these animations. And made the animator controller for them. So that was actually a really cool and fun process. One thing that you may notice as well is I've added a weapon, and I've actually added effects and particles and things like that to the weapon when it's being fired. So I have the muzzle flash there and the bullet trail, and right, think that from some resources and actually some tools that are here in Unity. Something you may also notice is that on the sides here, I actually have completed images, and something that's a little more faint that you may not notice, but it's still kind of there, is I actually have some parallaxing going on in the background. As you can see, you can watch the movement of the stars move at a different pace in the foreground than in the front, and it actually looks really nice, especially in comparison to what it looked like before. Something else you might that's also kind of cool is I've actually clamped the camera respawner, and so that's something else that I've done there. So so let's kind of get into it, and I'll talk about some of the code that I've implemented, and kind of talk to you about the process that I went through. So this is MonoDevelop. This is actually the tool that's used for writing code in C# in Unity, and using this specifically is because it's actually really helpful in terms of having a lot of what would you call that? Reaction time to, or it's really visible, the things that you're doing and how they affect your game. So like, for instance, if I go to where my parallaxing script is located, which is in my game master object, which is located here. If I double clicked on that, this would pull up, and I can actually see where the different variables that I create, or the different objects that I create, are being implemented in the graphical interface. And so one example of this is right here. I have my public transform backgrounds. This is actually an array. And as I have, the reason why I chose the script initially to talk about is because I have everything commented out here specifically for you guys to kind of look. And so this array is actually a list of all the backgrounds and foregrounds that are going to be parallaxed. And that's actually listed right here. So I left it blank because I actually wanted to be able to decide the size of that background and decide which things went in there to actually have the parallaxing effects on them. I also have a private float, which is also an array, which actually is used to assign the proportion of the camera's movement to move the backgrounds by. And then I also have another effect called smoothing. And this is basically just determines how smooth the parallax is going to be. And that's also shown right here. The parallax scale isn't necessarily visible here because it actually affects the backgrounds and assigns based on the backgrounds. And so that's why it doesn't actually show up here, because it's not something you can actually change or edit in the game itself. So let me show you an example here real quick of how smoothing works. So right now I have it at 0.4. guess an extreme example I could show you of how the parallaxing works and kind of the differences. If I were to assign it a value of 1, the effect of the parallaxing actually becomes a lot more prominent, and it's kind of going crazy in the background. The stars move all over the place, and the foreground kind of like moves at a slower pace. So that's kind of what happens when you increase the value there. I like it to be a little more minute. That's kind of like a personal preference thing. I do like the depth that it kind of brings and the realism that kind of comes from having that effect in there. And so I guess one of the goals and objects of me performing this project is that I really wanted to be able to develop a C-sharp script from the ground up. I didn't know that this was going to happen, but I've already done that a couple of different times. And this parallaxing script is just one of my stronger examples of that, mainly just because I took a lot of time to really kind of understand each part and commented it out so that I could share it with others. And so let's go back into the script here, and I'll kind of talk my way through it. So if we go into here, I have a private transform. This is camera, and it references the main camera's transform. It's actually a reference to the main camera that's here implemented on one of my objects, and there's actually a 2D script that's assigned to that. And so I also have a private vector here, which has the previous camera position, and it's pulling this vector, or it's pulling this type of variable in here so that I can use it later in my code. So I have this particular part of my code that's called before the start for the references. So I have my camera, which is going to be equal to main camera.main.transform. And then I have this part of my code, which is actually used for the initialization of the different methods I'll be using. So at this point in this code, I actually have my previous camera position being equal to my camera position, which basically just states that it's assigning my camera position to the previous camera position. Sorry, that kind of sounds weird, but it's less complicated than what it actually is. So, and then on here, I'm assigning my corresponding parallax scales. So my parallax scales is going to be equal to the length of the backgrounds. So that's assigned over here. When I put in 4 backgrounds, there's going to be 4 parallax scales that are assigned to each one. And then the assignment of those parallax scales to those individual backgrounds actually happens within this for loop. And that occurs here. So to 0, which is less than, or as long as I is less than backgrounds.length, you would add an additional one. So parallax scales is going to be equal to whatever I is, and that is going to be equal to whatever in the position of where we are in the foreground loop. And then we're going to times that by a negative value. That's the reason why I put this in there. It makes it smooth better, and it makes it parallax properly. It's kind of hard to explain. It's something I kind of picked up in a guide. So the update function here, I have this one for every background. Basically what this does is the parallax is opposite of the camera because the previous frame is multiplied by the scale. That's actually what happens up here. The parallax is equal to previous cam minus the camera position times the parallax scale. And so that basically is what causes it to move at a different ratio. And then this sets the target X position to the current position plus the parallax. So background target equals background's I dot position plus parallax. And then down here we have a vector that creates a position in which the background's current position with its X position. And so that's referencing this up here. So the vector 3 dot background's target position is equal to background target positions, background's dot I positions Y. And this just assigns the values on the scale that's on there. So there's a Y value, there's an X value, and there's a Z value. So, and then here is kind of where some of the smoothing comes in. It fades between the position and the target using lerp. Lerp is actually a function that's within Unity. And I didn't actually do a whole lot of research into what it actually does. But in some of the guides I've been reading about LARP, this was the best way to implement this. And so I have my backgrounds, the target position. Here's the smoothing aspect of that, and that's, well, the whole thing is kind of the smoothing aspect of it. But this is the smoothing times delta time. That actually just means that it's going to be in real time. And then here we have the end of the sequence where the previous camera position becomes camera position again. So I hope you were all able to kind of understand that. Things I've also implemented that I could show you. Back into the game here, I want to show you something real quick. As you can see, I actually have my arm following my cursor. That was actually a kind of a cool script that I was able to make. Let's see if I can't pull it up here. Arm. And then I have my arm rotation script here. I'll get that pulled up. So here is my arm rotation. As you can see here, once again, I have a variable here called rotation offset, which is actually visible here. It's normally preset at 90, but I've actually set it to 0 because that's, when you have it set to 90, it actually faces the opposite direction of whatever your cursor is. And so just depending on the different sprite that you're using, sometimes this comes in handy. So this update is called once per frame. So basically what happens is you want to subtract the position of the player from the mouse position. And you have to kind of take into account the local area of where the target is, which is your player, and the world area, which is actually based off of this grid system. So everything has a position. 0, 0 is actually straight in the middle, and anywhere else between that has a different X and Y axis. And so this is actually the formula that I use. So we're normalizing the vector, meaning that all sums of the vector are equal to 1. And then here we have the float. It's actually taking the difference of Y and difference of X, and then we're changing it from radians to degrees so that I can find the angle in degrees. And we're transforming the rotation. And that's the rotation offset there. Okay. So some things that I'm kind of struggling with. I have yet to figure out how to get my camera to reset on my target after it responds. As you can see, it doesn't move at this point anymore. And so that's something that I'm currently troubleshooting. And may end up just kind of giving up on altogether. We'll see. Generally speaking, because I may just want to actually have the game completely start over after death instead of having a respawn. But kind of see it as it develops and things like that. The next couple of things I want to do is I want to actually develop spawning features for different AIs that you'll actually be targeting and trying to kill. And survive in, kind of the basis of the game, and actually get the gameplay of the game kind of moving forward rather than having it just kind of be this scene. So the other thing I also implemented is I have my Game Master object, which has the parallaxing script in there. I also have a Game Master script, which actually is responsible for killing my player after he falls after a certain boundary. Additionally, I have a player script that's assigned to my player, which is located right here. And in my player script, you can actually see a couple different things. I've actually implemented a player health stat, which is equal to 100. I've implemented here these public stats so that you can actually call it anywhere. And I've implemented a fall boundary, which is automatically set to -20, but I actually have it set to -10. So that actually references as the world scale. So if I fall between 10, I have this function that's called, which is called so if transform position.y is equal or is less than the fall boundary, we're going to damage the player a really big number, so it just instantly kills you. And so if player stats is less than or equal to 0, we call the game master, which is that, and you kill this, which is actually referencing to the current object. So if we go back into the game master, click here, I can actually see where it tells me to kill the player, or where it calls the kill player function, which is right here. So public stat void player destroy player.game object GM does start coroutine. All right, and this is where it actually destroys. This right here is actually where I have my respawn player, and so it actually will respawn right here on the spawn point that I actually have verified. So just want to thank you all for listening to this video. If you have any suggestions as to different methods that I could use to kind of reset my camera, I can actually show the camera here. So if I go to the main camera and go to my 2D follow script, I've actually tried a couple of different things, and I'm still not able to get it to respawn. So at the moment, so that I don't have any errors, I have an if statement here, which says that if the game object find player clone, which is my character, is equal to none, it's going to return. But I have this statement here that I was hoping that would change it so that the target is equal to game.object find player clone transform. I was hoping that with this line of code that it would actually find that target again, but I have not been able to get that to work or implement correctly, and I'm not exactly sure why. So if you have any opinions or any methodologies that you think that might be able to correct that, or if I'm flawed in my logic in this statement, please let me know. So all for watching, and I hope you have a great night.